In this lesson, we're going to take a look at currying functions. Essentially, currying means breaking a function with many arguments into a series of functions that each take one argument, and the functions are chained together such that you have a function that accepts a set of parameters a, b, and c, and you'll break that into three functions like func a, func b, func c, which basically call each other. The whole purpose for currying is to get specialized functions from linking together more generalized functions. Okay, let's take a look at a regular function that doesn't use currying. So we'll have a function creatively called notCurry. That'll accept 5 parameters. And inside this, we'll just print those 5 parameters, and then we can execute notCurry, and we'll pass it 1, 2, 3, 4, and 5. And nothing special happened here. This is the type of function we've been working with from the very beginning. Now, let's take a look at what a currying function is. This is going to be very similar to what you looked at with closures. However, this is going to be a little different than a closure because instead of the purpose being to maintain state and returning a function from a method, we're still going to return functions from a method. But the whole idea is we are going to take this one function that has 5 parameters and break it into a series of functions that takes 1 parameter each. And so we'll have a bunch of nested functions. So let's just call the first one curry, and that'll accept the A. And inside that, we're going to define another one, and I can call that curry2. That'll accept the B. And you can pretty much guess what the next one's going to be. And then 4 will accept the D, and then we'll have curry5, which will accept the E. And it's going to have the exact same function on the very inside here. It'll be the print. But when we finish with curry4, remember curry5 is being defined within curry4, we have to actually return the reference to curry5. Likewise, this is going to return the reference to curry4, curry3, and then finally we are done because we're defining curry A as this function definition, which we're going to return. So in that perspective, this is very much like any other high order function that returns a function. But the difference here is that function on the inside of curry, which returns another function, is a function that returns another function, which contains a function that returns a function, etc., until finally at curry5 is when we return the entire result. And to call this, I'm going to say curry, but instead of passing it as 1, 2, 3, 4, 5, because if I tried this right now, we're going to have a problem because it says it only takes 1 positional argument, but 5 were given. What I actually have to do is say curry1. Now if we look at curry1, what is that going to do? It's going to pass 1 in for A. And then once we're in here, it's going to return curry2. But because of the closure rule, A, which is defined inside curry5, it is a nested function of curry that accepts the A, it is going to retain the state of that value. So in fact, what we get back is another function. So we could say C2, or just say C is equal to curry1, and then we can print C. And you can see that the value C is actually a reference to curry 2. If we wanted to actually get to the part where it prints, we would have to call curry 2 then with some value. How would we do that? Well, remember, this is actually a function. So C is a function. So we could actually then say, and it's probably better to say C2 is equal to curry 1 because it does return a reference to curry 2. C3 would be equal to C2, and we'll pass it a 2. And then we could say C4 is equal to C3 and pass it the 3. And then we could say C5 is equal to C4 and pass it the 4. And then we could finally pass C5 the 5. And you can see then it prints the 1, 2, 3, 4, 5. So we just did it one step at a time. We could, of course, call the entire thing in one shot by saying curry 1, and then pass it a 2, and then a 3, and then a 4, and then finally the 5. Because this is what gets passed to the curry A function here, which returns a reference to curry B, which we pass a 2 in for B, which returns a reference to curry 3, and then we pass a 3 in for the C variable to curry 3, which returns a reference to the curry 4 function, which we can then pass a 4 into for D, and then likewise we get a reference back to curry 5, in which case we pass in a 5. And we could hit run. And we can do this in several steps as well. We could say temp is equal to curry 1 and 2. And then we could say temp 3, 4, and 5. So first we're going to get a reference to which one? Well, we call curry with a 1, which returns a reference to curry 2, where we pass in a 2, which basically gives us a reference to curry 3. And then it's going to retain in that temp call, because of the closure, the A and the B are going to be cached. And then essentially then temp is a reference to curry 3, where we're going to pass the 3, the 4, and the 5. And we still get the 1, 2, 3, 4, 5. Okay. This is probably where you're ready to tune out going, why on earth would I ever do something like this? And you wouldn't be wrong. This is, again, one of those solutions trying to find a problem. A lot of people consider currying. But in reality, it is a very useful way to chain very generic methods together in such a way that we can build more complex problem solving. So let's take a look at a more concrete and useful example. Now that we got the basics out of the way of what currying does. Let's create a function called compose. And compose, well, actually I'll call it compose2 because we're going to compose two things. It'll accept two functions. And we'll say a function A accepts a parameter x, which is going to return a call to the f function. By the way, f and g are going to be function parameters. We're composing two functions together, much like we did here. So it's going to be f, which calls g, passing it x. And we're going to return a reference to the a function. So essentially we're going to create a sequence of functions that are going to be linked together, and we're going to refer to them by whatever comes out of this compose2 function. So this a represents the function that will tie f and g together. Okay, not super useful yet. Let me put it into hopefully simpler terms. feet to inches. Now, as you could probably guess, this is going to be a conversion function that takes a number of feet and returns the number of inches. Well, that's just going to be value times 12. Okay, so if we have 1 foot, it's going to be 12 inches. 2 feet would be 24 inches, etc. We could also define miles to feet. And then we will say value, there we go. We want to say return value times 5,280, because there are 5,280 feet per mile. Okay, so we've committed the compose to and these two conversion functions to the kernel. Now we could say convert, we're going to say miles to inches. That's going to be the name of our function. And we're going to set it equal to the result of compose to, passing it miles to feet and feet to inches. And we could say an inch is equal to convert 1. So let's see if what I've typed in here is correct. We have this compose to function, which I'm passing miles to feet and then feet to inches. So F represents miles to feet, and then the G is represented, or represents the feet to inches. According to this, it's going to execute feet to inches first, and then it's going to execute the miles to feet. Seems to me if we wanted to convert miles to inches, these two have to be flipped around. Or more precisely, maybe we have to do G on the outside here and F on the inside there. So it'll do the miles to feet conversion first, then the feet to inches. Since these are simple multiplication conversions, you won't see a difference in the result. But if we were to start to do different operations like divide or square roots, where the order is going to very much matter, then we definitely have to make sure we get the order right. So yes, I'm going to put the G on the outside and the F on the inside, because it's going to take whatever the result of f of x is and pass that to the G function. So it's going to do miles to feet first and then feet to inches. And what this inch is doing, this variable, is it's being assigned the result of convert miles to inches 1. So I'm passing it 1 mile, and it should return the number of inches. So let me print inch. I'll make sure I rerun these because I did make a change. And we get 63,360. Now let's check to see if that makes sense. I brought up a calculator here. We know there are 5,280 feet per mile, and we need to know how many inches that is. We multiply by 12, and we get 63,360. So that was correct. Now, if you wonder why we have this type of functionality, it's because we can define every step of the way in the imperial system going we have miles to feet, feet to inches. Maybe we'd actually have miles to yards, then yards to feet, then feet to inches. And then we can have something like a conversion from inches to centimeters. And then from there we can have centimeters to millimeters, or centimeters to meters, meters to kilometers, etc. And when we have all of those functions available, these little simple conversion functions just going from one to the next step, up or down, we can start to chain them together, and pretty soon we can convert from any one type to any other type. And you just have to know how to chain the methods together. So let's actually take this one step further, and I'm going to define kilometers to miles. And I just happen to know that to do this conversion, I have to take 0.62137,119 and multiply that by the incoming value. I don't have it memorized. I did have to look that up. And so now we have the ability to convert from kilometers to miles. Let me go ahead and run that. And then I want to be able to compose 3 items together. Well, it just so happens there's a neat little lambda I picked up online which allows us to do this very operation by using the reduce function that you might be familiar with from mapping, filtering, and reducing. But for me to do this, I have to go to the top here, and I'll insert a cell above, and I'll say from functools import reduce. Okay, so what this lambda is going to do is recursively bring many functions together and compose them into a chain of calls. It's pretty much doing what we did in compose 2 here, but it's doing everything recursively by taking for every function that was passed in, it's going to chain them together by calling one after the other. So let me go ahead and commit kilometers to miles and this lambda into memory. And then I will create a new convert function. I'm going to go kilometers to inches, and I'm going to set that equal to compose. I'll do kilometers to miles, and then we'll have miles to feet, and then feet to inches. And then we can say inch is now equal to convert km to inches, and we'll pass it, let's say it's 7 kilometers, and we'll print inch. Let's go ahead and run that, and it's roughly 275,000. Now this compose method is actually fairly complex, not because it's doing a lot of work, but because it's using the keyword lambda 3 times. You can simplify it a little bit by removing that initial lambda and changing it to be a traditional named function, and we pass in, instead of this a capital F, let's just call it functions, and it's a little easier to understand. So now we have a list of functions being passed in, and we're going to use the reduce function on that list of functions. Reduce basically takes each item in the list one at a time, performs some operation, and passes the result of that to the next item in the list. So that's essentially what we're doing here. So this is just another way of writing it. As you can see, the internal lambda is pretty much the same. We have the f of g of x, and that's what's really going on here. It's just a little cleaner now because we got rid of that first lambda f, or star f, saying that we are just going to use a traditionally named function here.